Welcome to this new project, BetterSplits for iRacing, which try to find solutions for a better matchmaking for multi-classes races. Very new things will be introduced in this version. If you just have a couple of minutes right now, this video will start with a 5-minute quick show of what results can be for latest special events like Petit Le Mans, Le Mans and Daytona. And of course, if you want to know everything, you can stay with me for the entire video. Just a quick recall, we try to get consistency between classes of any split to avoid situations like today, where we experience big iRacing gaps between, for example, beginners in prototype and skilled GTE drivers. So let's start with Petit Le Mans. We will start now comparing. So on the left window you will see the algorithm, which is very close to the current one of iRacing, and on the right window I will show you what the very last algorithm can deliver right now. So first with iRacing, here we start to have big difference from the very first splits. In split 2, for example, we have 3.3k versus 5.7k. Here 2.5 versus 5.1 on split 3 already. It starts to be annoying already right here. And more we go in lower splits, more problems are important. Here, for example, we have 1.5k only versus near than 4k. Or here 1.4 versus 3k. So let's try now the new algorithm with the same race file. As you can see, the average difference is now been reduced from 49% to 11%, which is a lot better. There is also more splits which can experience a multi-class context. We have only 3 single class splits now versus 6 before, so you have more chance to experience that. And if we look at any split line randomly, we can see every driver is now out the right place. For example, on the bottom here we have 1.6 versus 1.6k. Here 2 versus 2 versus 1.9. Here 2.5 versus 2.6 versus 2.4. Here 3.1 versus 3.6, not bad. And on the very top we are good too, even if we allow more difference. I will explain you why later. It's because we want to allow that. So this case is interesting because we have very few C7 here. So some splits can be alone, like here, GTE only, but they are alone with the guarantee to race with drivers of same level for an interesting race instead of being mixed with other classes with a totally different skill. To help you understanding how this algorithm works, we can randomly pick a cell on this table. For example, here we have a soft of 2.0k, or this one of 2.0k too, and the algorithm try to match with the upper and the lower bounds of the corresponding GTE class. So here we have 2.0, and it's the right place because it is after 2.1 and before 1.8 here. So the right split or line to match is the split on the middle of that. And we can do this verification with any cell. For example, here we have 2.4, it is lower than 2.7 but upper than 2.3, etc. Another example with the 24 hours of Le Mans now. We see the first 4 splits are pretty nice, but it starts to be less good from split 5, 6, 7. And things really come annoying from split 8, because we have here 1k of difference between LMP2 and GTE, and more we look down, more things are going annoying. Here we have half of the soft of GTE and LMP2, and we got the same problem a bit lower here, on splits which are only 2 classes only. GTE of 2.5 are mixed with the very lastest P1, which are 1k only. Same race, but new algorithm. This time again, the average difference is really improved from 31% to 9%. You also have more chance to race in a multi-class experience. We have only 2 splits which are GTE only now versus 5 before. And once again, if we randomly look at split line, here we have, for example, 3.2 versus 3.2 versus 3.4. Here, 4.2 versus 4.6 versus 4.5. Here 2.6 versus 2.4 versus 2.4. Here 2k, 2k, and 2k, which is pretty good. 1.7 versus 1.6 versus 1.6. So yes, at any level, it's quite impressive. and it uses the same rules as I have previously explained. So if we randomly look at this cell, which is 2.1, it's here because it's lower than 2.2 in GTE but upper than 1.9 here. Same exercise now at Daytona. We start to have big difference around split 6 or 7. For example, here we have 2K C7 cars versus 3K GTE cars. And obviously, more we look down, more differences are big, like previously. Here we got 1K for Corvette, which are mixed with 2.5 GTE on the same splits. So it's a huge difference. It's more than 2 times here. If we try our new algorithm, it succeeds to reduce the average difference from 37 to 10%. More splits are multi-class this time too. Before we had 5 splits which are GTE only, and now we have only 3 splits in that case. Every driver looks to be in the right place now. Here for example we have 1.6 versus 1.8 versus 1.7, which is pretty close. Here 2.9 versus 2.7 versus 3.1, so everything is nice. And we have the same effects than before. If we pick for example this line of 2.1k, it is upper than 2.0k here and lower than 2.3k, so that's why its best place is here. Now we will try to see if our algorithm is still good on more and more small races. We will start by an IELMS in 6 splits, which is one of the time slots of the lastest 7 hours of Le Mans. So if we look at the iRacing side, the split 1 is nice. Okay, we have 1k difference between HPD and GTE, but the difference is only 18%, so we cannot complain about that. Split 2 is okay, a little bit more difference, but still okay. Split 3 is the big problem. We have 1.5k P1 versus 3k GTE, so this time again it's more than 2 times more, and we finish with 3 more splits which are single class. With the new algorithm there is only 1 split which is now single class. All the others contains 2 classes or more, and you can see its success to group driver or sum level this time again. On top split we have 3.5 versus 3.7 versus 4k. On split 2, 2.7 versus 3.1. Then we have 2.2 versus 2.4, 2.0 versus 1.6. And now all the beginners can race together in a multi-class splits with 1.4 versus 1.3 versus 1.3. And they can race all together without being erased with 4K drivers now. Let's try on an even smaller event with 4 splits only in IMSA. This time it's not a team race. On iRacing side, there is a huge difference in split 1 due to the 3 DP with only 1k of soft, 3 beginners here, which are mixed with 4k GTE drivers. So it's exactly conditions we all love, or not. And if we try our new algorithm, it is what you get. Split 1 contains only 2 classes because there is no C7 to match with it. These 3 C7 are now in the very bottom split, where other classes are also around 1k off. It's more logical. Split 2 is turned to a single class now. And in split 3 we have GT3 and GTE around 1.5k. To finish with concrete example, we will try on a race with 2 splits only, again in IMSA, a sprint race. We can see in split 1 everything is mixed again with the iRacing version. We have C7 with only 1.4k mixed with 3.2 GTE and 1.7 GT3. If we try the same race with our new algorithm, now we have that. C7 are now in the bottom split, a bottom split which is now consistent because in front of the 1.5 soft of the C7 we have now 1.2 for both other classes. And in split 1 we have taken the half of the GT3. We will discuss on that detail later. It's an option which is possible in certain conditions. And split 1 is now consistent too because are together GTE of 2.7 and GT3 of 2.9. So if you are now convinced about these results, maybe you want to know how does this algorithm works. We will start from 0. Here we will take an example like ELMS. Several drivers subscribe to the race in 3 classes. And we can apprehend that with 3 waiting queues where P1, P2 and GTE are waiting for being attached to a split. Where this algorithm is really new is before starting moving any car anywhere, it will run a workflow of 3 processes. Step 1, predictions. Step 2, statistics. And step 3, decisions. The prediction process will first reveal all the possible combinations for the next split. In this example, there is 4 possible predictions and we can apprehend them with 4 cards. The first one is the hypothesis of using all the classes. The second one is to avoid P2. The third one is to avoid P1. And the last one is to make a single class split. For this process, the only thing we need to know is the number of cars we need to get for any possibilities. We will discuss about that later. But number you see in green on the card here are number of cars we want to target for any case. Now a second process works like a statistician. It will calc the corresponding SOF of any cards regard to the driver which are waiting in the waiting queue. Each of the cards will be filled with these results, and the statistician will also try to calc every information which can be interesting later to help decision. For example, you will calc SOFs for the split we want to process, of course, but also for the next one. The difference between SOF classes will be calculated as percentage too, and other extra information will be added to this card. For example, to give you only one, a check will be done to know if on that card the minimum SOF of the current split is well lower than the SOFs of the next split. At the end, all that cards are given to the last process, a decision maker. This machine will process logical rules to choose the best scenario by keeping the cards which are matching most of programmed rules. You can apprehend that process like a successive filtering operation. Some cards will be excluded, others will be prioritized, and at the end we only keep the best one. Now the best card is chosen, we have the answer to our question. In that case, the next split will need 17 P1 and 29 GTE. We can dequeue this card to the waiting queue, and we can restart the step of these 3 processes for the next split. And we do that again until queues will be empty. If you want to look at this process working for real, you can try the test application yourself with the debug parameter set to 1. As soon as you will compute a race, with our new algorithm of course, the predicts log folder will be filled with several text files. Each file is corresponding to a split, and they totally matched what I've just explained with the animation. So if you look at this one, for example, here is the first prediction card containing 12 P2, 13 P1 and 21 GTE. Here you have the corresponding SOFs and all the other statistics we can get from that situation. Here is the second prediction card and its stats. 2 other ones are following here. And at the end of the file comes a section with decisions to get best title. And this part is logging the process of the decision maker. So it starts with the 4 predictions. Tests are made on them. Here there is very few tests because it's a simple case, but it can be longer than that sometimes. And at the end, after all the filtering, you will find which prediction has been chosen to go for it. Another way of understanding this algorithm is to apprehend it as a black box, but to play with its parameters. We will go back to the Petit Le Mans race and we will play with the parameters to show you effects they produce. So I start to set them to stupid values, and now you can see we have something closest than the today situation. So it's a perfect starting point to play with parameters. The first parameter is about car class repartition. There is now a new way of understanding that question versus the previous video. Now, and thanks to ideas of Yannick Lapchamp, we can define the value of the minimum cars we want to target in a class, the less populated one in fact. So here, this parameter is set to at least 10 cars. That's why, for rounding reason, we have 12 C7 everywhere. If I set this parameter to 14, now we have 14 or 15. And we have something really close to the current iRacing situation now. Let's compare just for fun. So this is the iRacing algorithm. And now if we go back to our bad parameters in the new algorithm, we have something really close. So this point is really interesting because it will allow us to balance better the car class distribution. Then we will look at the next parameters. It will be a group of 4 parameters that works together and which allow us to rule the maximum soft difference we want to allow or not on the same split. These parameters help the algorithm to decide if move down are needed or not by avoiding GT3 or C7 in this split or this split. So it works in 2 times. First we have a default value, which means we want to target in general something better than 17%. And the 3 other parameters are here to make exceptions to tune that better. So just let me show you if I decrease that. I have to decrease that too. So as you can see, more and more I decrease that parameter, more the algorithm is allowed to make move down because restrictions are higher. Percentage difference will become more and more lower because we filter them more and more. We are closing the possibilities if you want. And at this point, it starts to really look like the demos I've made on the first part of this video. But now the 3 parameters here allow you to tune that better, to make exceptions, because it's not something really relevant to check always the same limit in every split. For example, if you have 1k difference between 5k and 6k driver, in general it's not a problem. All the guys are really good and could share the track together. In the other end, if you have 1k difference comparing 1k to 2k drivers, you can have huge difference between them and you can start to have problem on tracks. So that's why these parameters are here. You can say, in general, we want to target 17%, but after that, we can say when softs are higher than, for example, 2.8k, now we can target 18%, for example, and we can add 11% tolerance more for every extra k. So it's a formula, an affine function, and if you click on that link, you can open a preview table to see formula results. So if we refer to this table, our rules are now we want 17%, but for specific soft, we will try to match this preview table. So if we are in a soft of 3.4k, for example, here we are okay with 24%. With 4k, we are okay with 31%, etc., etc. And these extra settings are a great solution to fix the problem of first split, which were not multi-classes here, because there were too much difference in terms of percentage between the C7 and the GT3 GTE, which was stupid. So here we can define exception for the very best driver. There is another interesting parameter too, that one called IR. If you remember the previous video, it was an option to cut the entire list on 2 parts, to split drivers with more than this rating and drivers with less than this rating. So this parameter now works totally differently because it doesn't work globally on the list, but locally on a split class now. So this case never happens on largest races like that, with a lot of splits. So I will load a very small race to show you what it does. I will pick this race, which is an IMSA 3 splits race. So here we have an interesting case, and it's a case which happens very often when races are 2, 3 or 4 splits, and where a class is only in 1 split. If we look at the GT3 here, we have a soft of 1.9k, okay, but it is not relevant at all, because inside it, if we look at the driver list, we will find drivers lower than 1.4k and driver with more than 3k, even 6k here. So with this parameter, you can say, okay, Try to see if a cut around 1.7k can be a better prediction. The logic behind that is if a class contains driver with more than 2 times rating from others in the same split, and if this local list of driver contains driver with less than here 1.7k, our parameter, and it's the case here, we have driver less than 1.7. In that case only, with these two conditions, nevertheless, the mean core parameter, the prediction process will allow to suggest other cards with only the half of the cores here. And in that case only, it can be an exception to the mean cores parameter we've seen firstly, and that is the result of it. We now have 12 and 12. And of course, softs are now more relevant. So this parameter is an additional help to improve small races. I want to say everyday races. So I really think it's interesting too. And because that situation will never happen on big races when there is a lot of splits, it doesn't disturb, so you can keep it switched on. It will not break special events or big endurances. Just few words if you want to test yourself this algorithm. If you get the project on GitHub, you can take the subsession ID which is on iRacing results page. So here I copy that one. And in our tests application, you can click on the download other race button and paste the race ID here. If this series is scanned on ipitting.com website, which is the case for very famous multi-class races, then you can automatically download the corresponding CSV. The only information you have to set manually is the field size of the series, and then if you click the download CSV and load it, it will write the file on your folder. So you can see it here. And so you can make tests yourself with different algorithm or different settings in the algorithm. So if you really want to help me, be free to do that and to post feedbacks on the topic. If for a special case you don't have good results, it can help us to improve things. If you want a closer look to this project, don't forget the GitHub link available on the official iRacing forum topic, BetterSplits for iRacing. From here you can download all the project as a zip file, including the source code, which is open source. In this archive you will get that. The test app is in the folder finishing by .ui. Then you can open the bin folder and the debug folder. And here you will find the exe file and lots of CSV file I use for testing on my side. So you can do by your own same things that I show you in that presentation. If you are interested about the source code, again it's open source. You can go to the library folder and then open the calc folder. And here you will find every algorithm written here. For each of one, I try to write as much comments as I can, so there is a lot of explanation into it, which can help to become familiar with it. And if you want to use it outside from the test application, but in your own code project, you can check the sample folder and open the file howtocodeit.cs, which is a very simple example. To finish, thanks everyone for your feedbacks. As you can see, a lot of your previous ideas are in this project now. From now you are about 80% to say yes to this project, so thank you again. If you want to support this project more, please continue to vote and tell your mates to do that. Be free to post your feedbacks, what you think about this project. Of course it can be new ideas, but it can be also storytelling about splitting experience you had on previous races. For example, from the last video, we focused a lot on the Petit Le Mans example, mostly the split 5, which is really inconsistent. And we have here a message from the GTE winner of this split, which tells us more detail about his feeling about that. So it's really interesting. Thanks Christian to do that. For example, he tells us the traffic was often super frustrating. DP drivers were slowest than GTE cars most of the time, and field erased by GTE teams, etc., etc. It's really interesting to read. And if you have more storytelling like that, it can also help this project. Of course, try to be constructive and impartial. There is also an image for your iRacing signature if you want to support more this project. And of course, be free to share this topic, to share informations with your teammates. More it will be represented and more iRacing will consider us, I suppose. So again, a great thanks for your help, and we will try to move forward now. Goodbye everyone.